Okay, well, today we will go to discuss about one new chapter that we call it morphological image processing. This chapter and this part is important because we have some new concept which will help us to work on the digital image, uh, and especially some of the job is in binary image part, and uh, this process will help to detect more about components inside the digital image. In brief, if I wanted to tell you, we are here. Now, this is the morphological process that it can help us to little bit finish the cycle that we had and this image compression. We finish just object recognition and color image processing will remain. I think for around this week and some lecture of next week also we will be stopped for this morphological part, and then we have some MATLAB activity for that, and then we can go for the color image part and object recognition, and that this color image may be not much more, and object recognition also some few lecture we may have. Uh, it means that mainly half of this part is will be finished after we can cover this morphological process. These are the topics that today we will cover: introduction about, and then about morphologically based concept in the set theories, structure of element or SE, morphology at one glance, five binary morphological transforms, dilation and erosion, which will be the parts, some parts of morphological, and we will continue for the next lecture. Also, today Kaya will talk about his project for us, and we will see his project, and let us see what will be the next step. Anyway, first of all, what is morphology? Morphology by its word is the branch of the biology that deals with the form and structure of animals and plants. But in morphological image processing, it's used to extract the image uh, components for representing and description of ranging shape, such as boundaries, skeletons, and the convex hull. That this word it will itself will say that now we are working on the boundaries, and a skeleton in some image means that the image that we will enter, maybe this word itself, it shows the application and the place which this concept will be higher. uh, Binary image, that may contains the numerous imperfection. And in practical, the binary region produced by simple tree sorting are destroyed by the noise and texture. As we know, the binary image are a combination of 0 and 1, and this 0 and 1 figure at the boundary side may have some noise. What I mean that as you also do that job and convert, suppose, your image into the binary, you saw that the image of yourself after this conversion uh, And the boundaries and the sides will become corrupt. I mean, somehow they have some shadows. Somehow the line and the border will have some unshaped form. Also, specifically, when you zoom in inside your image, you will see that the pixels are not in the proper manner. And you know that this exactly boundary is nothing by the thresholding value, which should be uh, implement on the border side. Morphological image processing pursues the goal of removing this imperfection by accounting for the form and structure of the image. Then the aim of morphology become clear now. It's help to remove this problem inside of our image and also give the good shape for that. This technique can be extend to the gray scale image also and can be help us to remove the problem by this group of the image. Morphology, as we say, it's a branch of biology which work on the form and structure of animal. Then we have another concept that we call it mathematical morphology, which will be defined as a tool for extracting the image components that are useful in the representation and description of the region shapes. What application we can use with this image filtering? We can work on the boundaries extraction, skeleton, convex hull, morphological filtering, thinning, and pruning, which we will talk about these applications. And the language of this mathematical morphology is nothing by the set theory that we saw before in our maths books, but in one or two slides today, I will just review them. And a unified and powerful approach uh, we have in morphology to numerous image processing problems that we will talk later on that. Um, Sets in the mathematical morphology will represent the object in an image. As you know, we have the binary image that it can be 0 as black and white as 1. And the elements of set will be in the coordination of x and y, which represent of the pixel belong to the object, suppose z2. Then in grayscale image, we have the elements of the sets which in the coordination of x and y of the pixel belong to the object and the gray level of Z3. Then we have the image with the morphological image processing and attribution extend from the image. After this morphological process, if we want to look to this subject as the box or the inputs output performance. The basic concept in the set theories is something like this that all of you know aware about them. Suppose subsets, union, in intersections, and mutually exclusive, complement, difference, reflection, and translation, which all can be represented as the set theory. And our job is to use them uh, in the morphology concept. But let us see what are the logic operation which involving in the binary. We have pixels and image, and the principal logic operation which used in image processing are as and, or, not, I mean the complement. And these operations are functionality complete, and logic operations are performed on pixel by pixel basis between the corresponding pixel bitwise. Other important logic operation like XOR and NAND we have, I mean something like exclusive OR and not AND, as we know it as the NAND. And logic operations are just private case for binary sets operations, such as AND as the intersection and OR as the not complement. Means that this logic operation also can be defined in the set theories as we reviewed before in the math book. Okay, let us see one image which hire this logic operation on that. Suppose if I have the figure of A, then the not of A is nothing by converting the black to white and white to the black. And suppose if I have the image A and B, just see them as the pixel A and pixel B. Okay, or one part of the image A and one part as image A and one part from image B. Now, if I want to use this operation, I mean this logic operation on them, then the AND will be between A and B can be that specified part in the image, and OR, which will be combination between them. XOR is something like this, and not of A will be like this. Means that whatever area we have in the A, then the not of A and B will be something like this, as it specified. This image is meaningful because it has even more meaningful because in the morphology you are interfere exactly with these parts. I mean, as the border size of your image and parts which you have in your image, you have some small pixels that you should do some modification on them, or you should act on this um, border pixels. It will be something like this, as you will see. Then remember this in your mind. It's not bad idea, and will be the good initial knowledge about this morphology part. Um, Morphological image processing is the collection of nonlinear operation related to the shape or morphology of the features in an image. And the operation based on them or morphological operation will rely only on relative ordering of pixels value, not on their numerical value, and therefore are especially suited to the processing of binary image. Then the relative ordering of pixel value is more important in this operation. Uh, and morphological operation can also be applied to the grayscale image, as we said, such as their light transfer function are unknown, and therefore their absolute pixel value are of no or minor interest. Have this in your mind. We will talk about the use of grayscale morphological image later. We have one concept in morphology that we call it SE, or structuring element. Let us see first what is this SE. Um, SE is the small sets or sub image which used to prop an image under a study for properties of interest. The origin of the SP is indicated by some black dot, where SE is symmetric and no dot, it shows the origin is at the center of symmetry. And when SE is symmetric B, it means the reflection of B. When working with this image, SE must be in the rectangular array, padding with the smallest possible number of background elements. Image must be in the rectangular array, padding with the smallest possible, again, background elements. And for image, a background order border is provided to accommodate the entire SE when its origin is on the border. Uh, Morphological techniques will probe an image with the small shape of template, which we call this SE part, or a structural element. The structural element is pointed at all possible location in the image, and it's compared with the corresponding neighbor of pixel. Some operation test whether the elements fit with the neighborhood, while other test its hit or interest the neighborhood. The morphological operation on a binary image will create a new binary image in which the pixel has a non-zero value only if the test is successful at the location in the input's image. Here we have one image that you will see. A, B, and C are defined in them. A is the structuring element which fits the image. B is the structuring element hits or intersects the image. And C is the structural element neither fits or neither hits. If you have this pattern or this SE, then think these SE or elements as the pattern like this that we show here. And you can see here this pattern of elements, and you can move on different, or you can something like sweep or scan all the image parts. And this is probing of an image with a structural element. White and gray pixel have the zero and non-zero value also respectively. It shows that these four elements or this matrix of 2 by 2 will be sweep on the image, and three case of A and B and C can be occur for us after sweeping with the SE part. Okay. Then now with this view that we have about the SE or structuring element, we can say that it's a small binary image. For example, a small matrix of the pixel event, each with a value of 0 or none or 1. And the matrix dimension specify the size of the structuring elements, and the patterns of 1 and 0 specify the shape of the structuring element. And origin of structuring elements is usually one of its pixels, although generally the origin can be outside the structure. Suppose, as you will see, of the square of 5 by 5 elements, and with the different shapes, suppose diamond shape 5 by 5 or cross shape 5 by 5, which I showed here, and even for the square of 3 by 3, we can have one origin as specified with this pink color. And this is some simple structuring elements that we show here. Later we will talk more. Even this is the basic for the morphological part. We just review some parts. A common practice with SE is to have the odd dimension of a structure matrix and the region defined as the center of the matrix. Structuring elements play in morphological image processing the same roles as convolution kernels in the linear image filtering. As you remember, in convolution kernels also, we had one kernel that going to sweep all the image. Here also we have SE, which have the same work to sweep the matrix of image and move around that. When structuring elements is placed in suppose some binary image, if each of its pixel is associated with the corresponding pixels of the neighborhoods under the structuring elements, and the structuring element is set to fit the image. If for each of its pixels set to 0, the corresponding image pixel is also 1. Similarly, the structuring element is set to hit or intersect an image if at the last for one of its pixels sets to the corresponding pixel is also 1. Here, see again, we have two concepts of feed and hit. We have, suppose if you see that we have the structure of S1 and S2, and we are going to suppose consider the case of A, B, and C. Okay. Now, compare to the structure of S1 and compare the structure or the part that we select as A, you will see A place and S1, which we call it for the first one with the S1, it's feet. For the B, it's not fit proper, and for C also is not. And see, suppose for the S1, which S2, now compare with the parts of A, B, C, you will see that for the S2, it's fit on the A1. For the B also, it's fit, and for C, it's not happening. But what about heat? It's on A, you will see that it has the fits on the case of A and B, and also for the C also. But S2 is not even heat the section C that we collect and observe inside the image. The zero value pixel of structuring elements will be ignored. For example, indicates points where the corresponding value is relevant, and that was the main idea for the SE, that we can consider it as the sweeping uh, matrix or sweeping uh, image matrix. Next things that we should see is the morphology at one glance can be interfered with this concept. One is dilution, erosion, opening, closing, heat and mist transform, thinning, thinking, skeletons, or medial axis transform. These are what words or definition that will interfere in this morphological uh, word. If you want to review it very fast or have some very short description, we can have this idea that dilation is going to grow the image remain regions. Erosion will shrink the image region. Opening will structure removal of image region boundaries pixels, and closing will structure filling in of image region boundary pixel. Hits and miss transform, image pattern matching and marking, Thinning is a structure erosion using the image pattern matching, and thinking is a structure dilution using the image pattern matching. Skeletons and medial axis transform are the finding skeleton of binary regions. These shapes also shows the act of morphology on sample image. Suppose in dilation, you will see the region which grows, and also in erosion, you will see that these regions are shrink. These are uh, rest of our image processing lectures for morphological part, which we will go to talk about them in rest of uh, chapter of morphology. I mean, we can say this slide is the main point, or maybe the all point which we need to know about this morphology part. Uh, and this description is very nice, which I find from one white article and bring for you today. The reference of that article also I put at the end. If you want, you can follow and uh, find the website and use them later. But the whole parts and needed parts I extract for you, and you can study. Okay, now we will go to see them one by one, and also have the observation and also comparison between these parts. First is erosion, which is used for shrinking of elements A by using elements B. I bring one M at the end of this page. You will see that erode, shrink, and reduce are the um, parts or action of this concept. And erosion is for the sets A and B in Z2 is defined by some equation like this, as we show. And this equation indicates that erosion of A by B is the set of all points Z such that B translated by Z is contained in the A. Means that erosion can be used for to shrink or thin object in the binary image, remove the image components, how we will see later. And erosion is a morphological filtering operation in which image details smaller than the structuring elements are filtered or removed. Means that the image details which is smaller than the SE are gone, and the image filter which is bigger than that will remain. Okay, it can be the whole story even in one line. Um, to understand more, we will maybe review erosion or even dilution from different words. Even if I repeat some words or repeat one concept, my aim is that we can learn it better. Okay. Now let us see how this erosion will work. The principle is like this: the erosion operator takes two pieces of data as input. The first is image, which is to be eroded, and the second is usually a small sets of coordination points, which we know it as the SE, or same concept as the kernel that we have in the correlation. Uh, it is the structuring elements that determines the precise effects on erosion of the image input image. The mathematical definition of erosion for suppose binary image can be something like this. Suppose X is the sets of equation coordination corresponding to the input's binary image, and K is the set of coordinates for the structuring elements. Now we will have the Kx, which will be denoted as the translation of the K, so that its origin is at X. Then the erosion of the X by K is simply the sets of all points X, such as Kx is the subset of X. The mathematical definition for grayscale erosion is identical, except in the way in which the set of coordinates associated with the input's image is derived. In addition, these coordinates are 3D rather than 2D. Let us see better on one example. Suppose we have an example of binary erosion. Suppose that the structuring elements is something like 3 by 3 square with the origin, which we will take it as the center. Okay, we show it in figure 1. Note that this is the subsequent diagram. Foreground pixel are represented by 1 and background will be 0. Okay, then we have some set of coordination like this: -1, -1, 0, -1, 1 and -1, -1 and 0, 0, 0, 1, 0, -1, 1, 0, 1 and 1, 1. These are the uh, set of coordination point that we can have, and the structuring elements we chose here. Then to compute the erosion of the binary input image by this SE, we consider each foreground pixel in the input in turn. For each foreground pixel, which we will call the input pixel, we superimpose the structuring element on top of the input image so that the origin of the structuring elements coincides with the input pixel coordinates. If for every pixel in the structuring or in the SE, the corresponding pixel in the image on the red is a foreground pixel, then the input pixel is left as it is. And if any of corresponding pixel in the image are background, however, the input pixel is also set to the background value. For the example that we have, I mean the 3 by 3 structuring elements, the effect of this operation is to remove any foreground pixel that is not completely surrounded by other white pixels. You can assume the 8 connectedness, and such pixel must lies at the edge of white region. And so the practical upshot is that foreground and region shrink and hole inside the regions grow. We will, I think, we can observe and see these better in the MATLAB part, but this theoretical also we need to consider. See, suppose the set A that we have, and B is our SE with the D by 4, D by 4, as you will see here. And now the erosion of A by B will be something like this, which we can show it with this element of erosion of A and B, and it will shows the area of D by 8 and D by 8. And as you see, it's shrink. Okay, if you act by the B on the A, you will see that it's shrink. Okay, the other maybe you will see that the set A and maybe the set B, which can have the dimension of D by 4 by D, and then you will see that what it will happen on my uh, set A. it's become near to the one borderline after acting by this uh, function. Okay, let us see more examples. Suppose we have one square structuring elements, which is 3 by 3. And note that in the subsequent diagram, foreground pixels are represented by 1, and the background will show with the 0. Then the structuring element is now superimposed over each foreground pixel, something like input pixels in the image. If all pixels below the structuring elements are foreground pixels, then the input pixel returns its value. But if any of pixels is a background pixels, then the input pixel will get the background pixel. See here the structural elements that I have and the pictures that I have. And now it's going to sweep. Whenever it will sweep parts by parts, the parts which is common will remain and other parts will gone. And you will see that the result of the erosion of the image will be something like this, as we show on the image. Then, if we want to see again, erosion is of a binary image f by structuring element s, which we denoted fs, produce the new binary image in the sense that G equal to Fs with one all location of x, y of structuring elements origin at which that structuring elements fit the input image of F. For example, Gx1 is equal to 1 is S fits F and 0, otherwise repeating for all pixel coordination. You will see here the grayscale image, the binary image as by thresholding, and the erosion that you will see here. Now maybe the thresholding and erosion difference you will see better in this image, the performance. As you will see, maybe at these boundaries, suppose you will see that image is little bit become sharper, the binary, and even in the binary thresholding, you will see that here it's little bit blur at the border part. See the border of the word, okay? And maybe it's better that I tell you boundary region of the image. You observe it and compare, you will get a more idea about the job of the erosion. Just have a look for 2 3 seconds. I will give you time. Uh, you will get more idea. Suppose see the word of G. What will happen from grayscale to the binary and even for the erosion? You will see exactly this G. See, G here is changed, but with the binary and with the grayscale, it's little bit bigger. Even you can see the word of C. You can word of E, S, S. Okay. And erosion with a small, suppose 2 by 2 or 5 by 5 square structure element will shrink an image by stripping away a layer of the pixel from both the inner and outer boundaries of the region. The holes and gap between the different regions become larger and small details are eliminated. See the act of the 3 by 3 square SE, which I take from this uh, web page. When you see the erosion image here. Then, if now we want to speak more in detail, say that the larger structuring elements have a more pronounced effect. The result of erosion with the large structuring elements being similar to the result obtained by the iterated erosion using the smaller structuring elements of the same shape. If S1 and S2 are a pair of structuring elements identical in shape with S2 twice the size of S1. Then we can have f of S2, it's equal to f S1 by S1, which is erosion removes small scale details from binary image, but simultaneously reduce the size of regions of interest too. By subtracting the eroded image from the original image, the boundaries of each region then can be found something like this: f minus fs, f minus fs, where f can be the image regions and s will be the 3 by 3 AC or uh, dimensional, I mean the structuring element matrix that we have, and b will be the image regions boundary. Okay, that was the mathematical view to the erosion parts that we had in our concept. Um, I think now maybe if once more you will see some image, it will bring more understanding for you. Now, suppose here I think this image is not bad, it's good. That again you compare them, the effect of the erosion and the act of that on the image side. Um, Please compare the words because the next part that I want to uh, teach you it's about dilution, which maybe do the reverse action. Is that if the uh, erosion will shrink, the next part will not shrink, make it even big, expand it somehow. The word then the result will be a little bit different. Okay, uh, just have a look now for this. And now we can even, if you have any problem, we can discuss because next part I will start after the rest that we can have for 10 minutes. Any question, please? The, another concept that we should review is dilation. Now, this function will use to expanding an element by using the structuring elements B. Means that the SE in the erosion will reduce, but in the dilution will increase the shape of the origin shape that we have. Dilation of A by B can be defined with this following equation that we show here. And this equation is based on obtaining the reflection of B about its origin and shifting its reflection by Z. The direction of A by B is the sets of all displacements Z such that B and A overlap by at least one element. And based on this interpretation, the equation that we show there can be rewrite as something like this. I mean, the z which will belong to b, z, and which has the intersection between a from the society of a. And relation to convolution mask, we have flipping and overlapping. Means that how it will related to convolution. It's something like flipping and overlapping that we have there in convolution. We can have in dilation. Let us see how it's work. You know, this erosion operator take two pieces of data as input. The first is image is to be eroded, and the second is usually a small set of coordinate points known as structuring elements, also known as kernel. And it is these structuring elements that determines the precise effects of the erosion on the input image. The mathematical definition of erosion for binary image is as follows. Suppose that x is the set of illusion coordinates corresponding to the input's binary image, and that k is the set of coordinates for the structuring elements. Then now kx denotes uh, then kx denotes the translation of k so that the origin is at x, and then the erosion of x by k is simply the set of all points x such that kx is a subset of k. The mathematical definition of grayscale erosion is identical, except in the way in which the set's coordinate associated with the input image is derived. In addition, these again coordinates are 3D than the 2D part, same as the erosion that we have before. If we want to see the example again of some binary erosion, suppose that the structuring elements one we have here, and now you will see that the origin at the center is specified, same as the previous uh, work that we have. Then to compute the erosion of the binary inputs by these structuring elements, we consider of the background pixel in the input image. In turn, for each foreground pixel, which we call the input pixel, we superimpose the structuring elements on top of the input image so that the origin of structuring elements consists with the input pixels coordinates. If for every pixel in the structuring elements, the corresponding pixel in the image under it is the foreground pixel, then the input pixel is left as it is. And if any corresponding pixel in the image are background, however, the input pixels is also set to the background value. Suppose for that 3 by 3 SE, the effort of this operation is to remove any foreground pixel that is not completely surrounded by other white pixels. Such pixels then must lie at the edge of the white region, and so the practical offshoot is that foreground regions shrink and holes inside a region grow. Here is some example that you can see the set A and again SE of B. Now you will see that against the erosion part in dilution, you expand the shape. And suppose for next one also, it's happening. If you remember in the erosion, that was one line. Okay. Then a more interesting example or bridging gaps is that historically, certain computer programs were written using only 2 digits rather than four. This is the text that we have. Okay. You will see that in the sample text A, we have some poor resolution, which in the same sample B, we have a structuring elements, and the C is the dilution of the A by B, as you will see here. C suppose some words, E and A, which become bigger, and the resolution of them, it's a little bit become change, as you will see. You will see the sensible change in this even example here. See, it's similar to the words are become bold in the image. Then we can say dilation of an image F by a structuring element S can be denoted by these Fs, which produces a new binary image with one in all location x and y of structuring elements origin, at which that structuring element S hits the input image F, for example, Gx and Y is equal to 1, and if S hits F and 0, otherwise repeating for all pixels coordinates. Dilation has the opposite effect to the erosion, and it's add the layer of the pixels to both the inner and outer boundaries of the region. Here you will see the binary image and the dilation effect on the image. But what will happen here, suppose see the word of image and some other words now due to something like bolding or expanding of the word, now maybe the quality is not good. Remember that every algorithm in image processing depends on the application and it's not fixed or it's not something like general that in all case you can use them. Now, even you will see that dilation has the opposite effect to the erosion. It's add a layer of pixel to both the inner and outer boundaries of the region. Think for the that M shape that we saw inside and outside of that. What's happened for the boundaries and the work? Okay, result of dilation or erosion are influenced by both by the size and shape of the structuring elements. Dilation and erosion are have the dual operation in that they have the opposite effect. Suppose if we let FC denotes the complements of an image F, for example, the image produced by replacing 1 with 0 and vice versa, formally the duality is written as something like this, F by S and the sort, where S sort is the structuring elements is related rotated by 180, and if a structuring element is symmetrical with respect to the rotation, the sort or SRT S rotation does not differ from S. If a binary image is considered to be collection of the connector region of the pixels set to 1 and the background of the pixels set to 0, then erosion is fitting of structuring elements to these regions, and dilation is the fitting of structuring elements rotated if necessary into the background, followed by the inversion of the result. We have now one concept, which in that we want to show that we have the duality between the erosion and dilation as and we want to consider them as the mathematical equation. You will see that this is the erosion and next one is the dilution, which represent in equation 2 also we have the same case as you will see first see the third one. A minus B also can represent us again the dilution part and so on. Then dilation and erosion are dual of each other with respect to the set, completion, and reflection. That suppose you will see the reflection and complementation. And these are the equation which shows the relation between the one of the simplest use of this erosion is eliminating the irrelevant details in the term of size from some binary image. Here, this is the supposed image of a square size of 1, 3, 5, 7, and 9, and 15 pixels on the sides in the sample A. B is the erosion and of the A, and C is the dilation one that you will see. Means that in the dilation one, just some notable parts is remain, And in the erosion parts, elements of 30 pixels on the sides are they are complements. Then let us see erosion and dilation difference. In erosion, we will shrink or thin object in the binary image, remove the image components, erode away the boundaries of the image for foreground pixels. Areas of foreground pixels shrink in size and holes within those areas become larger. In dilation, which grows or thickens object in a binary image, bridging gaps and fill small holes for sufficiently small size. That was the difference between the erosion and dilation parts and the concept related to them. Because if I start the next part, which is about opening and closing, I don't know how much time Kaya need. I think 20 minutes also if he take with talk and that. Uh, I will now hand over to Kaya, and then if we had time again, we will come back and talk about what we can say about the rest of the concept that we have. Any question till now? This part will become more clear if we go through the MATLAB section of that. That I plan for that. Don't worry. We will see some example, and you will understanding better.